Good morning. Today's the topic is the penetration depth as well as BCS theory. So penetration depth is a short answer, and the BCS theory is a very important expected essay from the unit 4. Now move to the penetration depth. So the penetration depth is represented with the letter lambda. Okay. Now what is the penetration depth means? If we have a superconductor, okay, let us consider a superconductor. So the distance from inside the superconductor, okay, the distance inside from the superconductor, at which the magnetic flux decays into, okay, when the magnetic flux decays to y by e of the 1 by e of its entire value from the surface of the superconductor, then it is known as the penetration depth of the superconductor. Kindly listen, the distance inside from a superconductor, okay, there are distance inside from a superconductor, at which point the value, okay, at which point the magnetic flux spreads to decays to 1 by e value, okay, 1 by e of the its total value of the superconductor from the surface of it. So that distance is termed as penetration depth. Okay. Now according to the formula, we can write it as lambda of 0 is equal to under root m by mu naught ns e square, where m is the mass of the electron, ns is the number of super electrons, and e is the charge of an electron, mu naught is the permeability. If the temperature of our conductor, okay, superconductor, if the temperature of the superconductor exceeds the critical temperature of the superconductor, then the super electrons will be going to become zero. What are the super electrons? Okay, the super electrons are nothing but the electrons which produces zero electrical resistance or the high conductivity in the superconductor is known as the super electrons. So in the superconductors, the super electrons are the main part, okay, plays key role in the part of the superconductors, which is the electrons are responsible for the conductivity, high conductivity in the superconductor. So as the temperature of the superconductor, normal temperature of the superconductor exceeds our critical temperature, then the super electrons will become zero. As the super electrons will become zero, the penetration depth will be infinite. Then as the temperature becomes zero, then okay, as the temperature is below the critical temperature, then the number of super electrons will be going to be increased. As we decrease the temperature less than the critical temperature, then the number of the super electrons will be going to be increased. As the super electrons increase, the penetration depth will be minimized. So what the relation we can make? Inverse relations we can make. So as the super electrons increases, the penetration depth will be minimum. As the super electrons will be zero, then the penetration depth will be infinite. So if we make a relation with respect to the temperature, what the relation means? As the penetration depth increases, okay, the temperature will be also increases. As the temperature is decreased, the penetration depth will be going to be decreased. Then finally, the mathematical expression for the temperature and the penetration depth is given as lambda of t is equal to lambda of 0 1 minus t by dc of 4 power 4 under root. This is the empirical formula for the penetration depth. Calculate the penetration depth. This is the formula. Now let us make the RHS of numerator of RHS the denominator of LHS. Then lambda t by lambda naught is there. Then under root will be there for the denominator. So if we move towards upwards, denominator minus 1 by 2. So 1 by 2 is there, under root is there. If you shift and under root to LHS, then you will have a square on LHS part. So we know the relation between the super electrons and the penetration depth. Okay, we know the value inverse. Okay. Then if we compare 1 and 2 values, equation 1 and 2, what we can find? The RHS are both are equal. Then LHS should be equal. Lambda t by lambda naught whole square is equal to n naught by s. From it, lambda t is equal to lambda of naught whole power 1 by 2. So this is the relation between the penetration depth and the number of super electrons. So lambda of t indicates the penetration depth at temperature T. The penetration depth at 0 Kelvin. Then this is the number of super electrons. Okay. Now move to the next topic as the BCS theory. So BCS theory clearly explains about the superconductivity. Okay. So the main topics are like isotopic effect. Okay. Misner effect. Right. So all this explained about the superconductivity, but the BCS theory developed a lot about the superconductivity. Okay, it clearly explains how the superconductor behaves and what are the main key parts who plays a key role in producing the higher conductivity in superconductors. So BCS represents as B for Barty, C for Cooper, and S for Schiffer. So these are the three scientists who proposed the BCS theory, okay, on the superconductivity and the superconducting nature. Now, so BCS theory explains about the Cooper phase. Okay, so later on we know what is the Cooper phase. Now, it clearly explains about the electron-phonon electron interaction or electron-lattice electron interaction. So by this, what we have to understand in BCS theory, the BCS theory developed due to the explanation for explaining the superconductivity. So yeah, the superconductivity nature is explained by the Cooper pairs in this theory. So what is electron-electron interaction? Means in normal nature, if an electron collides with another electron, there will be a repulsion. Okay, but according to the BCS theory, if an electron will interact with another electron, there will be an attractive pulling force will be developed. So we will know what is this attraction between the electron and electron. Always there will be a repulsion between any two electrons. But here in this BCS theory, he proposed an electron-electron interaction. So due to this electron-electron interaction, okay, the superconductivity nature develops and also it produces the higher conductivity in the superconductor. Now let us consider an electron. Okay, let us consider an electron with the vector, with the k as a vector. Now, if an electron collides with the ions, what is the question here? Electron-phonon electron interaction or electron-lattice electron interaction. So the electron is going to be interacted with another electron with the help of a lattice. Okay, lattice ion. Lattice is nothing but an atom or an ion. Okay. Okay, if an electron moves with the certain momentum, okay, with the vector k, then it collides with the lattice point. Okay, so if an electron is moving with a certain momentum collides with an ion of a lattice point, then after some part gets scattered. Okay, some parts will be scattered. That scattered has certain momentum as k minus q dash. Okay, so as the electron is interacting with colliding with the photon or the lattice ion, what happens? Some parts get scattered and some part will be going to get transferred. Okay, let the ion be q. Okay, let the ion be q. Now again, if these lattice ion with an electron coincides with the or collides with the Generally, the electron, if we collide with another electron, there will be a repulsion. But here we develop today force of attraction between the two electrons. So clearly listen, the electron will collide with the lattice ion with certain momentum. Then some parts get scattered with certain momentum, and some part of it get moves with the another ions. As the ion moves from one place to another place, again it collides with the secondary electron or the another electron. So the electron and photon, the electron and the lattice ion will share the momentum of first electron. So let us consider this as the first electron and this as a second electron. Okay. Now the first electron is going to be coincide with the ion lattice ion. Then some parts scattering, some parts will be moved from one place to another place. Then while moving this ion, so around the ion it acts as a positive charge. So why this attraction means, why the electron is going to be attracted by the other electron means, as the colliding occurs, so around the ion it develops a positive charge, invisible positive charge. So that positive charge attracted by another electron with the help of a lattice ion or phonon. Okay, this is known as electron lattice electron. So this electron pair is nothing but electron pair is nothing but Cooper pair. What is the Cooper pair? The pair of two electrons with opposite spin. So now one electron will have the negative half spin and one electron will have the positive half spin. Finally, the resistance of both the electrons will be, the spin of both the electrons will be 0. So 0 indicates that as the electron has a 0 resistance, what happens to the conducting nature? So if it has a 0 electrical resistance, then this Cooper pair will produces the higher conductivity. Okay. So this is the theory of your BCS theory. Okay. Now in Cooper pairs, okay, in superconductors, the Cooper pairs will be developed. Okay, means the electron pair will be developed. So these continuous formation of the Cooper pair forms an higher superconductivity. Higher conductivity will be going to be developed due to these Cooper pairs. So kindly observe that the superconductivity nature is due to about the formation of Cooper pairs. As large as the Cooper pairs moves from one place to another place, or the flow of Cooper pairs produces the superconductivity. Okay, the superconductivity behaves with an 0 electrical resistance and the higher conductivity due to these Cooper pairs. Thank you.